Hi guys, we're live. We're just gonna wait a minute or two for other people to join before we get started and do introductions.
You know it's bad when people are
already
the
pre-warning.
presenters already know. Exactly. People watching already know. It's too fast.
That's okay. It's better than too slow. I've had a few people where I'm like, I could do it 2 times speed, and I still have quite a good legibility of what they're saying. So
Right.
Okay, so maybe we'll get started. We've got enough people in the room already.
Okay.
So, hey everyone, welcome to Substrate seminar officially. It's part of the DevHub team. I'm Addie. I'm one of the members of the DevHub team. I work with Dan and Joshi, Ricardo, Jimmy. We keep you guys hopefully happy with our content and lulls. So I'm here today with Sean, who's one of our core devs. He's going to do some introduction and information around Rust traits and Substrate runtimes. I just want to remind you all that there's ask a question box at the bottom. You can ask a question. Otherwise, I'll keep an eye on the chat, and if there's anything that comes up there, I'll try to insert it into our conversation as well. But feel free to ask questions. Nothing is too dumb or too complicated, hopefully. So, Sean, I don't know if you want to introduce yourself, but feel free.
Sure. My name is Sean Tabrizi. I've been working a lot in Substrate for the last, I guess, almost 2 years now. Hopefully you've seen me around answering questions in Riot or, producing other content. And yeah, I'm really excited to present some interesting stuff today. I think the goal of what I wanted to cover today is kind of taking the perspective of someone who's brand new to Substrate and kind of maybe even new to Rust and seeing some of the syntax or some of the weird things that you don't quite understand. And hopefully trying to explain those things kind of more simply. I think, I'm not sure if everyone programs this way, but I'm the kind of programmer who I'm kind of okay just like copying, pasting, working code and just trying to get a feel for kind of how things work at a high level, making small changes, seeing if what the compiler errors say, and, just kind of keep tweaking it. But at a certain point, you start to dive in deeper into like, how do these things actually work? I'm not just gonna copy paste code. I want to know exactly how it's created or what is underlying structure being built. And ideally, in this presentation, I can go over some of these things and give you all a little bit more insight into what's actually going on underneath the hood, and hopefully make things more simple for people who want to interact with stuff or even make modifications and stuff. So that's kind of the perspective. And if I touch something that you, or if I don't touch something that you want to know more about, definitely ask a question, and maybe I can dive into other nuances. I think the hardest part kind of about doing a presentation like this is that, having worked with Substrate for 2 years, you take for granted like all the things you just assume or all the things, I can't look at the code the same like I've never seen a code base before. So this is the kind of thing where definitely your feedback and kind of the things that you want to know more about would definitely allow us to create more content, which can kind of demystify Substrate. Yeah.
Cool.
Okay.
Sounds great.
So I'm going to present my screen. So the way I'm going to approach this is we're going to look at a little bit of code. Let me first share my screen. Let me make sure this looks right. Yep. So one thing we're going to do is we're going to be, and make sure that everyone can see this, right? One thing we're going to do is we're going to make sure that we're not doing any Substrate magic. So we're going to be starting with empty projects, brand new Rust projects. And everything we're going to be doing today is like purely 100% real Rust. Okay, so no magic that comes from Substrate here. I think this is going to be really helpful. And then we're going to maybe take a look at Substrate real quick, and then maybe point out some of the pieces which I am claiming are kind of weird at first, and then maybe we can go into the details. So the first topic I want to touch into is this trait. So if you're familiar, when you're constructing your runtime, you have a bunch of palettes. These palettes all have individual pieces of logic. You bring them all together into this runtime, which is actually composes the full logic of your blockchain. And if you want to add these palettes to your runtime, one of the things you need to do is you need to add this trait that comes with every palette. So you can see frame system has this trait with all of these types basically in there. You can see that timestamp has the same thing, balances. Every single palette will have some trait definition. And this is a little bit weird, I think. I think, at least when I first took Substrate, it didn't really make sense or understand why it's happening this way. Like, was this magic, or is this maybe some design principle? And so what I want to show you here is that if you were to create some basic Rust code interacting with like multiple different modules or structures, and you want to share the idea of types kind of across them, and even have the idea of generic types. Again, one of the most powerful things about Substrate is that none of these types are defined ahead of time. So you can have a balances where your balance could be represented with different types, underlying types here. And so if you want to build a system like this and have the kind of generic flexibility that Substrate has, that going into this trait syntax is actually really natural, and it's like a normal part of Rust. Does that make sense, kind of where I want to set up? So to basically do this, what we're going to do is we're going to be creating basically like some Rust modules or some Rust structs, which kind of act like these different palettes. So as I mentioned, I'm going to be starting from scratch here. Okay, so there's going to be a little bit of coding. We're going to definitely maybe run into some errors. Hopefully we can debug them all. But to start here, give me 1 second. Let me set up real quick. So I'm just going to create a new folder. So let's do trait example. And then I'm going to start a new project, right? So cargo init. Okay, great. So we have a new project. I can cargo run. Yep, and here we go, hello world. Awesome. Okay, so I'm actually not going to be using this main part. I'm just going to be creating a bunch of tests using some structures I defined. But basically, to begin with, we're going to create a new module, a Rust module in this case. We'll call it step 1. That's what I've... actually, before I even get into all this, maybe I should say real quick that if you want to follow along, if for whatever reason, I'm coding too fast or there's something you want to look back at, there are 2 projects I have which will cover the 2 things I'll be talking today. So if you go to my GitHub, which is Sean Tabrizi, maybe we can link this in the chat real quick. Okay,
yeah, I can link it if you can't.
Yeah, I'll link it real quick.
Okay, thanks.
And Robert asked, do we need the playground? So actually, you don't need to use the playground for this. The playground's really useful if you need to compile Substrate and you need to get all the Substrate dependencies running. But actually, what I'm going to be doing today is purely in Rust. So as long as you have Rust installed on your computer, it should be way, way faster just to do it on your computer. So this is one of the advantages here. But so I have these 2 small tutorials, and this is what I'll be doing. I'll be basically following along with these tutorials and explaining kind of how I constructed it. Okay, so now that I've shared that, so we have the step 1, okay? And so what I'm going to be doing here is I'm going to be creating a balances module. And so in reality, the Substrate has, kind of a more complex system of how it stores data, how it manipulates data, all that kind of stuff. But from a very high level, you can kind of emulate the behavior of a balances module by basically having a single, like storage item, which keeps track of all the balances of all the users, and a couple of functions which allow you to basically manipulate those balances. And so that's what we're going to do here. So what we're going to do is start with, and again, this is, all regular Rust. So if anything is confusing, please call it out. So here we go. I'm going to do a pub struct balances module, okay? And as I mentioned, this balances module, this structure is going to have 1 item in it. So it'll be balances, and I'll use a hash map. Again, this is a more primitive Rust type, which maps from a U32 to U32. So this would be representing like, some account and some balance here, right? And this will basically be our main structure starting point. So now we have basically a object that can store some data. So now we need to implement some functions for it, right? So now let's implement some functions for balances module, or the balance module. The first one I'm going to do is an initializer. So basically, when I want to create a new instance of the object, I can implement this function new, which returns itself, and it will return basically an empty version of the object. So balances hash map new. And obviously, actually, one thing I already noticed is that because I'm using hash map here, I'll probably have to import it. So let's just do that real quick. So use std collections hash map. Okay, so this will allow me already to create a new balances module. So let's see if I can actually start setting up some of this framework so we can do kind of step by step. And then I'll be moving a little bit more fast moving forward. But I think from the beginning, we want to make sure that the basic stuff is working. So basically what I'm going to do here is I'm actually going to test already what I've written is kind of like already working. So I'm going to write a new test. and we'll do function test step 1. And basically, I'll create a new instance of this structure. So I'll say let mute balances. Actually, I don't need to be mute yet, but it will need to be mute later. Let's just do it for let balances equal step 1 balances module new. And what I'm going to need to do actually is import this step 1. So I created a module here. So I just need to do mod step 1. Let's make sure I didn't do anything dumb. Actually, I think it's balances module. That's what I want. And ideally, if I do from this point, I think I can just do cargo test and it will work. Yeah, okay. I got some warnings. No big deal. But it does compile. It does. I can instantiate a new balances. So now this is not really interesting. What we need to do is we need to add more functionality. We need to add all the things that allow us to basically interact and move and transfer things and stuff, right? So before we can transfer things, we actually need to set some balances. So, I'm going to add a kind of like a backdoor and allow us to set any balance of any user. So I can do pub function set balance. I will be dealing with a mutable reference myself because of course I'm going to be updating this storage with this function. So I need to be able to mutate the object that I am working with, self, and then I'm going to say who is some U32. And amount is also a U32. Again, that's these two objects here. So this is a map from this user to this balance. and basically this set balance, all we're going to do is going to do self.balances.insert who amount. So this is basically, a backdoor which says, our balances object is a hash map, and I can insert. This is an API of the hash map, the who and the amount. And so this already will allow us to get some balances in there. So again, I'm working a little bit slowly to start with. So let's test this work. So I have this. Now we're going to be mutating it. So I want a mute balances. And basically, I should be able to do something simple like, set the balance of a user, right? So I can say balances.set balance. User 1 can have 100 tokens. And balances.set balance user 2 can have 200 tokens. And assert, let's make sure that this is correct. So I should be able to check balances.balance. So this is me querying the storage. And I should be able to return that the balance of user 1 is equal to 100. And I should be able to assert the same about balance 2 equal to 100. Okay, and after this compiles, I'm going to take a look back, see if there's any questions about what's happening so far. Again, the idea here is that this is not exactly how Substrate works. Obviously, there's a database and there's much more interesting storage operations. But I'm emulating kind of the basics of stuff, and I'm doing it all in pure Rust. So that should be kind of what we're getting away here. Ooh, actually, I need to create this function balance. I can't just query it directly yet, but I can do that real quick. So anyway, I've set balance. Maybe if I comment out these two function. It should be able to work, right? So this set balance function is implemented. I need to basically now implement something that's going to be querying. But first, I'm going to take a quick look at chat, make sure there's nothing I'm missing. Nope, looks clean so far.
One question was, is there a mapping in Rust, and how is it different from a hash map? I answered it underneath, but you're welcome to iterate.
So is there mapping than Rust? So hash map is how I would do a map in Rust, but I think there are other structures that probably exist that can do similar things. Hash map is obviously a pretty simple one. It's common, from key to value. Cool. So we have this function set balance, and now we've set some balances, and that does work. But now we want to check what is the balance of a user, right? And so this actually, I will in here go into one of the finer details about Substrate. So let's create a function which allows us to read the balance. So I'll do pub function balance, and this will get some self. So it doesn't need to be mutable here. I'm just reading, and I want to know who I'm going to be reading the balance of, right? U32, and this is going to return a U32, a balance. Okay, and then to get this, I'll do self balances dot get who dot unwrap or 0. So this is an important part right here. So it may not be that every key has a value, right? So in the case where I call get, I'm actually going to be getting a result. One of the tricks that actually Substrate does too is that when we query storage, if there is no value there, we would return normally none. Like there's no value in that storage you're querying. But what we do instead is we unwrap OR and return the default value. So it would be actually something like default, right? And so it basically says when there is no value, tell the user there is some value, right? And so this makes sense in the context of balances, because whenever a user hasn't had a balance set yet, we can basically assume their value would be 0, right? And so this is basically what this function is doing. It's basically getting the value. If there is a value there, unwrap it. If not, return the value 0. And so, and with this in there, I think it should all, this step should be working too now. Let's do this. And you can see, by the way, because we're running normal Rust, everything compiles much quicker, and everything is working, right? And I could even do one more assertion here with that extra step, that the balance of 3 is 0, right? Wow, screen sharing is like definitely lagging my screen. It's a little bit disorienting, but that's fine. So you can see here. So we see here that we already have some like working module. We can set balances. We can query the balances. Everything is looking good, right? So now we need to add some basic transfer functionality. I think that's the last piece of this puzzle, right? So let's now add a transfer function, right? So pub function transfer. And we obviously are working with a mutable reference of ourselves, right? So we're going to be changing storage here from some user to some user for some amount. Okay, and then I'm not going to go into like super deep about all the logic I'm going to be adding here, but obviously when you're creating a transfer function, you're going to need to do all the checks that users have enough balance, that that you don't overflow, etc., stuff like that, right? And then also, this transfer function may fail. So if it fails, I want to return a result. So this is the exact same kind of result object that you might be expecting when writing an extrinsic function. So either it will return OK with nothing else, like nothing inside of it, or it will return some static string, maybe with some error message in it, right? Okay, and so basically, to make a transfer function, I'm just going to do it like this. I'm going to get the from balance equals self.balances.get ampersand from dot OK or from user does not exist, right? So this is basically getting the one user's balance. The let to balance equals self.balances.get to unwrap or 0, same thing as before. Right, so now I have the original from balance and the original to balance. So there's going to be a new from balance. So that new, there's probably some more clever way to write this, but I mean this is pretty clear, hopefully. Checked sub. So we're using checked mathematics here, right? We don't want to overflow or underflow in our math operations. This would be bad, right? No overflowing or underflowing. And Rust helps us do this by basically giving us these checked operations. So the new from balance is going to be the original from balance, check sub the amount. And if the check sub doesn't work, we can do OK or this user does not have enough funds, not enough funds. And then we're going to use the question mark operator to basically finish that off. And then let the new to balance equal, and it's a little bit slow to start, but again, we'll start picking up quick once we get this code written down, and then we just start copying and pasting a lot. Add amount, OK, or, oops, this is the lag. No. OK, amount dot OK, or, and then we can have an overflow here. Overflow, right? The user got too much money. It's a kind of a good problem to have, I guess. Overflow. Thank you. And then once we know that the new balance, the new from balance, new to balance is good and nothing is wrong, we can just insert these values back into storage. Balances dot insert, and this is actually very much, if you look at the balances palette, very much exactly how our balance palettes work actually. There's obviously a lot more kind of handling when you create new accounts and you do other kind of stuff like that. But this kind of basic logic is exactly how it works on our side too. So nothing magic there. The insert to new to balance.
Can you explain in the line 19 when you're calling the balances and you return the and zero versus instead of a zero? What's the logic for that?
Yeah, I think this is just a Rust thing. So Rust is expecting a reference to this zero value. So if you were to not return and zero, it would just complain like, hey, it's expecting a reference.
Got it. Okay.
Yeah. It might be because I have a pointer here. So again, it has to kind of, it's one of these things that, you know, if you write it the way you would expect, compiler will just kind of yell at you until you get it right. But yeah, I think that this is basically dereferencing this reference here.
Got it.
Yeah. I will say I definitely wrote this wrong the first time around. I'm kind of writing it right now because I know, but compiler would tell you these problems. Okay, so so we wrote our transfer function. Hopefully this makes sense for everyone. And so now we should be able to do some basic transfer stuff, right? So here we're just going to do a basic transfer from one user to another. So let's assert that this works. Assert balances.transfer from 1 to 2 of 50 is okay. Oops, that is okay. Okay, so let's just test this real quick. Ooh, checked sub. Oh, so I probably need to import some things into scope. Oh, maybe not. Let me see. From balance. Checks. Oh, it's because I didn't add a question mark here. See, so what's happening here is that this is returning a result. And what I want is actually I want to unwrap the value, right? So if I add this question mark here, it'll take this result object, which either has an error with this message in it, or OK with the value in it, and I am adding the question mark to either return the error or give me the value into from balances. And this is what this error is saying. And that's why I have a question mark in all of these. The question mark here in all of these basically will return the error string if there's an error there, or it will put the value that I want into the variable. Okay, so this works. Let's do a couple more sanity checks just to make sure that the functionality is doing what I expect. So if we transfer 50 from user 1 to user 2, we would expect the balances to be updated. Oh God, the lag is really killing me. Okay, so balance of this guy should be 50, and this one should be 250, right? And then we get also, I'll just add to it just to speed things up. So this should pass. And then if I try to transfer more money than we have allowed, obviously we're going to get an error. So I'll assert that balance transfer of 100. So we've already transferred 50. Now they only have 50 left. Another 100 is an error. And we should confirm that the balances don't change. That makes sense, right?
And where are you inserting the declaration for the balances?
Sorry, what do you mean by that?
It says, where is the balances.insert declared?
Balances.insert. So I'm up here, I'm setting balances. So at the very beginning of my test, I have this backdoor function set balance where I'm setting the balance of user 1 to 100 and user 2 to 200. And this set balance function calls into this set balance function, which just calls insert, which is an API of the hash map. So basically, I'm just directly putting in some value.
Got it.
Right? Okay, so let's. So I've written all this test. Hopefully, it makes sense to everyone, and if it runs, it should pass.
One question I just see Joshi has is, when I was new to Rust, I found the question operator kind of confusing / magic. I've seen you expand that to the logger, but more explicitly with Rust in the past. Can you show that again?
Yeah, sure. So actually, let's just take an example of that real quick. So instead of using the question mark here, why don't I just write the normal Rust code, right? So this code here will be a result object. Okay. So instead of writing the question mark, I can match on the object. And I can either, if it's error, with some error message, I can, oh God, the lag is really killing me. Return error, error E. And actually, I think I was told that this is dot into. So we don't need this dot into, but I guess this is what the question mark operator would do. And otherwise, if it's okay with some value, spit out the value. So this code, basically, this return here would actually return the whole function early, right? So I wouldn't process any more code here because I'm returning from the function early with some error. And so this is what this result would expect. I'm returning some error here. So as soon as I hit this part of the code, bam, I'm done. But if it's okay and I have some value, this value is the value that will be returned and inserted into this from balance. And so when I write the question mark operator, I'm basically just not writing those 2 lines of code every single time, which I think we can all agree is better, right? Okay, great. So everything is passing. Now you have a kind of a look into, maybe I didn't save. Maybe I should make sure I didn't actually write. Yeah, I think this should all be fine. Okay, so now we have a look into, we have a balances module that's working and it does stuff and it changes things, okay? So let's talk about what is bad about this. Well, one thing that's bad about this, and if maybe you are cringing when you see me write this, look at this. U32, U32, U32 everywhere, right? Like, how do you know what this is supposed to return, right? This is not helpful at all, right? That we have some U32 return U32. This could be, for example, returning another account here, right? So we may want to give things types. Additionally, let's say I wanted to quickly change, the type. I don't want who to be U32. I want it to be U16. Well, dang, I would have to go through and search U16 everywhere and change everything. It's not good, right? So what we can do is we can take this code and we can iterate on it. So let's make a copy of this. Copy, paste. Okay. And let's call this step 2. Sorry, the lag is, Jesus. It's really killing me. I have to basically spend a second between each thing. Okay. So one thing we can do to improve this is actually define some types. So this might not actually be the best way to define types because I think these are just aliases. But for now, I'm just going to look at aliases. But something like this would I think be nicer. So type account equals U16. So I want to change it to U16, right? And then type balances, or maybe just balance, equals U32, right? And then what I can do everywhere is just kind of change the usage here, right? Oops. Oh, God, the lag. Account. Balance. And you can kind of see where I'm going here. So this would be kind of one step in a better direction here, where now if I wanted to change the types again, I would only need to update the type alias up top. And also, yeah, one thing that this doesn't do is if I had these 2 types be the same alias, if they were both U32, they would actually still be interchangeable. I could still accidentally pass an account as a balance. And one way you could solve this is actually using a, I think they call it an identity struct. I won't be going into this here because I think that's a little bit just going into a hole that is not quite super helpful. But let's see, 2 is account. But I think hopefully you get this idea. This already is better code. Sorry for the lag. Balance. Okay, am I missing anything else here? Probably, nope, I think that's it. So here we have an alias, and I can try a new test just to make sure this alias works. Maybe for the sake of speed, I'm just going to change this test 1, or I'll make a new test. It's just copy and pasting. Yeah, if there's any questions, now would be a good time while my computer lags and I copy paste code.
There's a question that says, what is the single apostrophe in transfer params add static str.
Oh yeah. So okay, to be honest, that's a good question. That's something actually I probably don't know the answer to. So this apostrophe I think is just part of this static name. This is like a known, what do they call it? Known keyword in Rust. And so I think this is just saying that this string is static. It's not a changing string. It is known at compile time. And so this string bytes will be hard coded into your binary, right? Versus like a more if you use the string object, this is this is something that is flexible, can be changed, it allocates the memory. And also if you use like an str object without the static, it also can be variable and changing. But this static type of thing is really just saying like this is fixed strings, right? So these strings could not be manipulated if you wanted to use them or change them. The apostrophe, I have no idea what the apostrophe is for. Maybe someone else can answer that. But as far as I know, the apostrophe is just part of this static type or part of this keyword. Okay, sorry, let me just finish this real quick. So I'm going to test step 2 instead. And basically all I have to do to change step 2 is basically change, instead of step 1, I use step 2 to instantiate it, and everything else should be the same. So let's cargo test again, and let's see that, oops. Of course, you need to declare the module, step 2. If no one said that in the chat, you're not paying attention enough. Okay. So this is already, I assume this will work. This is already a step better, right? But even still here, what we've done is we've hard-coded these types, these aliases into the module, right? This is not the flexibility that Substrate provides you. Substrate provides you with the flexibility to define the types in your runtime configuration, right? And so this, I think, can be really illustrated well if we had 2 different modules with who want to use the same type. So right here, we just have balances, right? And I think there are simpler solutions for just one thing. But let's say we have 2 modules, a balances palette and a voting palette. And the voting palette, we want to use the same notion of accounts as we have in balances, right? So this is actually, I'm just going to copy and paste some code from my example here. It should be nothing crazy, but this will just save some time. Step, please go. Step 3.rs. And I'm going to basically introduce another module, basically another structure that has some different logic, but also wants to use the same account type. So I'm just pasting this from off screen. Yeah, so you can see here it's basically the same thing, right? I've defined these account ID and vote index types. I basically have the same thing, a hash map, which is a tuple of account ID to vote index. So each user can have a vote on different voting indexes and can vote some true or false. So here, this is the key. The key is an account ID vote index tuple. So me on index 1 or me on index 2, and I vote yes on index 1, no on index 2, something like that, right? And the logic here is basically the same. I have something that instantiates a new object for the new struct. I have a vote function, which is simple. It just inserts the value, and a get vote, which gets the value. Dead simple. Don't need to rewrite this. And you can see here I've already taken advantage of this this type alias stuff, right? So now let's say I have these two modules, right? But here, the account ID here is actually different. So let's see, I try to use the 2 together, and I should expect to see some errors. So let me see here. I'm probably do a little more copy and pasting just to save a little more time. I think I just paste an example of a test that will fail. And I will also make add a test that shows that the palette 3 is working, or module 3 is working. Hopefully I haven't been talking too fast here. I think me having to type code has forced myself to slow down a little bit. Also the lag. Okay. So I'm going to be just pasting some tests. Again, this is from the links I posted to. So again, nothing magic. I'm just saving some time here. But this test step 3 basically tests that the voting module works, that I can do some votes, right? I can get the vote. It all works there. And then this test won't work, right? So let's actually uncomment this. And so why won't it work? Well, it won't work because in step 2, I have account ID as a U16. In step 3, I have account ID as a U64, and these types are not, not necessarily inherently compatible with one another, right? A U64 can be bigger than a U16, right? And Rust won't let you do these kinds of things. So let me run this test, and hopefully we'll see an error. Oh, of course, and if this, man, let's see how many times out of 5 I'm going to make this mistake. Mod step 3. No space. Okay, let's try again. And so let's take a look at this test. This test basically is just combining modules. Yeah, perfect. Look at the error 2. It's combining modules 2 and 3. Basically, I've set up a balances module instance and a voting module instance, right? And I've also set up user 1 and user 2, right? Now, what Rust is really doing in the background is actually aliasing this type. So right now, we don't have any type definition here, but Rust will infer the type here. So really, basically this is the same as saying U64. So it infers the type. Or actually, the first time I use it is actually set balance. So it actually will infer as U16, I believe. Right? So U16. And then even if I didn't include this, it's inferring the type here with the first time it gets used. And then it's telling you, whoa, you're using a U16 here in a spot where a U64 is expected. Now, you can convert U16 to U64 using .into, right? But if, for example, this was a U64, and I'm trying to put it into U16, it's actually not super clean to be able to use it, right? It's not every U64 that will be able to convert to a U16, right? If I have some really huge number here, I would get a similar error message saying, hey, these types are not the same, right? And because I've hard-coded these types into the palettes, like, dang, I can't really touch that code. It's someone else's code, right? So you see here that it's now telling me because it's UC4, I can do try into unwrap. This is nasty, right? So you can see naturally that there's a problem here. Now, what we want to do is we want to actually share the types from these 2 palettes, right? And so we can do that. We can do that by introducing generics. And this is where some fun stuff comes in. So again, I'm going to be doing some more copy and pasting. I'm not actually introducing much new code here, but I'm just going to be avoiding doing copy and pasting. Actually, I'm going to copy and paste, and if people think it's too much of a jump, let me know, and I will go ahead and walk through it, because it is a little bit of a jump. But I think it's something that we can follow, especially if I walk through it. So, oops, give me 1 second. Why is this slow computer hate me so much? Step4.rs. Okay. So I'm going to be pasting in step 4. So what I've done here is I've taken the struct for balances module and the voting module into one module. So basically just, instead of having 2 files, I have 1 file. And you can see here, instead of using, I'm going to go jump to step 3 real quick. Instead of using this type alias, I'm going to introduce a generic parameter everywhere. And I can actually start to introduce that here just a little bit. I won't save so it doesn't complain. But instead of having pubstruct voting module and then these types come from here, I can actually get rid of this and instead introduce generics here, where this struct will have a generic type account ID and generic type vote index. And then then this type will come from this generic. And of course, I would need to implement here account ID vote index. And I think that also part of the generic stuff is that I have a trait definition here, account ID vote index. So this is what it might look like to use these generic parameters instead of using a type alias. Okay, so let's jump into my this should be working code. And I think actually that's all you need to change. So if I look at this vote index, let's scroll to the bottom, or the voting palette. You can see that's basically all I did here. So in the flag. The voting module, I have basically just added this account ID vote index generics. It picks up the types here. And okay, so what I missed here is that some of the errors you would get is you need to define some traits. And actually, maybe I can follow through on step 3, and we can actually go through some of these errors. But you can see the general idea here is that now I implement this struct using these generics. And then these types are basically defined not here, but defined whenever you instantiate the voting module. So there is some magic happening here, and I want to walk through some of the errors here. So the way I'm going to do that is I'm going to just continue iterating the step 3. I'm going to modify it. So I took something that had the hard-coded types, and I'm going to add these generics here. And so let's take a look at how we would have to modify the code to make this compile. So let's go back to main 2. So this is the step 3. So instead of saying voting module new, I actually here would define my traits. So I would say here, I want account ID. Let's actually just do this here. So type account ID equals U16, and type balances equals vote. This is a vote index. I'm sorry. Let's just do that real quick. Vote index equals U64. U64. And I can pass these types into the instantiation of the struct. Account ID, vote index. And this is basically the syntax for how you do that. And I think that this, so again, I think this will not work because I haven't defined in step 3 that these types are concrete enough. I haven't put enough bounds to be able to do all the things I want to do. So let's compile and see what the error message would be. Yes, and you can see here, Rust actually, so again, this is one of those things that after a while you learn that Rust compiler is your friend. But you can see here that in order, so what I've done here is generally correct. I've defined the generic types. I've implemented the generic types here in the instantiation of the struct instead of the module itself. But what it's telling me is that I actually can't do the logic I want it to do, because what it's expecting is that these that I haven't constrained these types to be anything specific. What instead I need to do is I need to define these types to have certain traits themselves. So in order for me to insert a value into the hash map, I need to be able to check that account ID can equal something else, and that also it's hashable. This is a hash map. I need to be able to hash these types too. So what I can do here is I can say that, okay, well, account ID is not only some generic type, but it's some type that must implement std cmp, that's compare, and then equal. It must implement this trait, and it must implement std hash, right? And I will probably need to do the same thing for vote index as well. And tell me if, so this is, I think, a point where people might start asking questions again. But you can see here that basically I'm just constraining it so that not any type can work as an account ID. Any type that I can compare two things to be equal and I can get the hash of the value will work. So let's see if now it compiles, now if it works. Function is never used. Function test step 3. Why is that? Did I forget to use test step 3? Oh, I forgot to put a test bracket over it. Test. Thank you, Rust. Now let's try again. Okay, and everything works again. So you can see here that the change I made was I took the struct, instead of giving it hard-coded types in the module, I added these generics. Okay, and I just basically added these types that I wanted to use everywhere. And in order to do that, I basically need to constrain the types to be basically functioning with the certain traits that are needed to make these functionality work. And the functionality here is basically just to insert into a hash map. I need to be able to compare two things that are equal, right? And I need to be able to hash a value. And with these type constraints and these generics, I'm now able to define out here in my world what the types of this struct is, right? And this is flexible. This is much, much more flexible, right? So now if we jump to, so actually I'm going to take a pause real quick. I'm going to take a look at the chat, see if there's any questions. Any questions? Polls?
Nothing yet.
Nothing yet. Okay, either I lost everyone or it's so clear that it's incredible. And so we're hoping for the second. But if you're not super familiar with Rust, maybe this is jumping a little bit ahead. But ideally, if you played with Rust, you're familiar enough with generics. I mean, we use it everywhere in Substrate, right? And there's one step better we can make this, but I just want to jump real quick back to step 4, because this is where, I copy pasted some code, but I've basically gotten to the point here that I did in the other code, where basically I've just implemented these 2 generic types. I've implemented the traits. You can see I just kind of, I imported the traits up at the top, so I don't have to do the whole definition like I did in mine. That's what I just did up here. And you can see I had to do something similar with the balances. But balances actually even had more constraints. So account ID also has equal and hash. But balance also needed the 0 trait, because I wanted to know that return a value is 0. It had checked add and checked sub, and also copy. So these are all the additional traits I had to do to balances to be able to do things like, hey, do checked mathematics on the balances. I need to basically know that this type will have these operations here, right? So what this really allows with step 4 is now I can create a test where I have 2 different modules, but they share some types with one another, right? And it will all work because the types are generic, and I'm defining them in my test. So I'm going to copy and paste the test real quick, and we'll walk through that test. Let's go back to main RS. Man, I hope you all can kind of feel the struggle I'm feeling with this lag. It is truly making me wish I had a desktop computer. Okay, so this is step 4. So step 4 has both the balances module and voting module with generics in it. And you can see here I've defined all my types I want. And you can see account ID here now is just one type, right? I didn't have the problem before where there were 2 different type definitions and they were running into errors. And now when I instantiate the balances module and voting module, I can use the same account ID type for both, and then have a different balance or vote index type for their respective needs. And they work together. I can use user 1 and user 2 in both kind of operations because they're all sharing types. This is much, much better, right? And it allows flexibility. So hopefully everyone's following here. Now, the one step better we can get to, right, is not to have to define 3 types and a bunch of generics everywhere, right? We want this T syntax. We've seen everywhere that it's just balance module T, right? You don't have to define all the types you would need. And to give it kind of an illustration of that, imagine how many types that you could possibly have. And if you look real quick back at system, or even balances. Balances has here 1, 2, 3, 4, 5, 6 types. System has some crazy number, right? It's a list. Yeah, this big ass list, right? You would have to, if you did it the way I was doing it, define a generic with comma separated values for all these different types. That's crazy. So what if instead I could define a trait which has all these associated types bundled together, and then just pass that one trait in there? And that's how you get to the final step. That's how you get to this syntax that we've gotten to here in Substrate. So let's do one more step, step 5. New file, step5.rs. And I think I will do this by hand, and hopefully we can run into any errors together. But to get to step 5, I'm going to take step 4, and I'm going to modify it. Okay, give me 1 second real quick. My computer is being nice and slow. Any questions so far? I'm jumping a little bit here. So if we're jumping in concepts here.
Come up if you have the capacity. One is, would you ever test the vote function with a value that is not U16 or 64, or is there no point to doing that?
Yeah, if you want to make the test more comprehensive, definitely you could. I mean, if you use a value that didn't accept like not a U16, the Rust compiler would complain at you, right? So you wouldn't even be a test that would pass. But I mean, you definitely could write more and more tests here. But I think for the purposes of the sample, the tests I have basically show, hey, I can submit a vote, it works. And it basically bubbles up the errors I want, which is that, hey, I have these 2 different types, and how are we making them work together, right?
Mm-hmm.
Okay, so in order to get this all working, give me 1 second here. In order to get this all working, I don't want to have to define all these types over and over. Instead, what I can do is I can define a single trait which will have all the associated types I know I need. So here I'll have T trait. So here is some generic type which must implement this trait. Now, naming is not super great here. It's what Substrate uses, so I'm just going to continue to use it too. But I'll have to define at some point some trait. Maybe I can actually do that first, and then you'll be more clear how we're going to use it. So in test 5, so test step 5, I don't want to define all of these types over and over again. What I'm going to do instead is define a trait. So I will say trait. And this trait says any object must implement these types. It must have these associated types. Oops. Gosh, the lag. Type, account ID, type, type, balances or balance, and type vote index. And actually, here is where I also will define what constraints should be on this type, right? This trait will define some types which themselves must satisfy certain traits, right? So I will need to import some things, but let's basically do the same traits we needed before. So account ID needs to have equal plus hash. Balance must have 0 plus checked add plus checked sub plus copy. And one nice thing is actually all these traits, I didn't really know what traits it needed. Rust compiler just kept yelling at me saying, hey, it needs these traits. I think I showed you that error message already. And you can just keep adding traits until Rust compiler is happy. That's generally what works, at least for me. Okay. And let's take a look at, let's take a pause real quick. So this is a trait which defines all the types needed to make kind of the whole runtime work. My runtime has 2 palettes. And this trait defines all the types needed for my entire runtime. And it has the list of the types and the traits they must satisfy. And this looks, this is exactly what it looks like here. We have some trait with some type, and it's implementing the type here. But if I actually jump into a particular palette, so let's go to frame system. Sorry, frame. Well, let's go jump to balances. It's just faster. My computer won't lag as much. When scrolling is actually a consideration for which files you look at. Okay. Let's scroll a little bit more down. We will see here that there is a, too much. That the balances palette defines a pub trait. This trait inherits from frame system trait. That's something we can kind of ignore for now. But basically, there's a list of types, just like I've written, type balance, type dust removal, type event, and a list of the traits that it must satisfy to be a valid type used in this trait. So this pattern here in our module definition, every single module you write is coming from us basically just trying to abstract away the types here. This is exactly the same thing that we've come to in our pure Rust module, right? So let me import some of these traits so I can use them the way that it's written here. Just gonna do a little bit of copy paste. Okay, so this is basically importing all those things, so I don't have to write down the full thing the whole time, and that would just be a lot more readable. And then I want to use this trait instead of using these different definitions. So the ideal world, right, is I don't pass all these different type definitions. I just pass here T, right, where T is this trait. So let me actually I'm just going to write the code that we want, and I'll make it work in the next step. And let's get rid of all. Actually, I can do this. I can say or I can do, sorry, it's not T runtime. So I want to do like struct runtime. So I'm going to create some dummy struct which will hold this implementation of this trait. And then I want to impl trait for runtime. So basically now I'm going to implement these types into my runtime struct. Okay. So now I've defined a struct which has all these types defined in it. And instead of passing T here, I pass runtime. I'm going to pass this struct which implements this trait and by such can derive all these types that I've defined. So this is the code we want to work, right? And we can already see this is much nicer. Instead of passing, common sense separated list of all the types we need, we just have one runtime definition with all of our types defined there, and we can pass it everywhere. So to make this work, we need to update our code, and we're going to, of course, be doing step 5 when this works. Step 5. And of course, I need to import at the top, and I need to change the name of that. I never tested step 4, huh? Mod step 5. Let's assume let's also add step 4 here. Mod step 4. And if I'm jumping around, let me know if this is too much for anyone. Hopefully, I'm trying to be patient enough to make it follow something that everyone can follow along with. So this is actually testing step 5 now. Okay. And so to make this syntax work, I just need to do a small update on the side of my runtime, on the side of my modules. So here, I will have that instead of passing all the types, I'll be passing a single object, and this object must implement this trait. And so I need to say what this trait is. So I will say use create trait. So this is basically pulling the definition that I defined in the other function. And probably if you were doing this, you would define things in slightly different places, but hopefully this makes sense. So basically now I have a single object which has a trait. And in order to access a count ID into this object T, I just do this. T : account ID. This is saying that of this object T, which implements trait, access this type, account ID. This runtime object implements trait. It has a count ID, U32. I pass runtime into balances module. And it's coming in through here. And now I have some object which has T : account ID. This is the type. And also T : balance. So this is where this syntax is coming from. This syntax that you use all the time, this is exactly how it's coming. It's coming because we have this type T, or this trait T, or this struct T, which implements trait, and we're accessing all of the internal types from inside of it. So basically, that's what I would do for this whole thing. So instead of all of this code here, I don't need to define all of this individually. I can just implement T : trait, and I have balance module T, and anywhere there is account ID or balance, I can just change it to T : Okay, I'm going to be doing a little bit of just going through my code here. So time for questions would be cool. That or brain explosion emoji would also be, I think, appropriate, because this is where the syntax come from. This for me was very weird when I first touched Substrate. It's one of those things I just copy and pasted. I knew it worked. I don't know why, but this is exactly why this T : type is coming from, and this is exactly why we have these T traits in every single module. This is the accumulation of why all of this is working. Is this everything? Okay, maybe I think here also T balance. Oops, that's the lag. Any questions? Any brain explosion emojis? I can't look right now.
Nothing.
Nothing. Oh, you guys are so boring. Let's try cargo test. We'll get some errors. Okay. Oop, there are some things not defined. Ooh, I just need to import like the num into my crate cargo toml file. Okay, so I have some dependencies here. I think I need to add num. Let's see how I do it in my example project. Yeah, this is another thing this is still kind of strange to me. But I guess Rust really loves this like import thing. Like it doesn't provide basic functionalities like checked math without you importing some crate. I guess that's fine, but in order to do that, just to do simple checked math, you need to import this num, or at least to have access to the traits which support checked math. Let's see what happens now. Okay, Will does brain explosion emoji. Thank you. Okay, are things going? It's thinking very hard. Oh, and it's also like a million degrees in Berlin. Oh my gosh, I'm in this room, and my computer probably is also feeling the heat. Whew, is it hot all around the world, right?
I mean, here it's been like 30 degrees, and then the next day is 10, and then it's 30 again. So it's just been all over the summer.
Wait, it's 30 and then 10 the next day?
Yeah.
Jeez, that is not even realistic.
I know, it's really horrible.
Okay, it's thinking a little bit. Okay, so now the time for any more questions. How is test coverage displayed? I don't know what that means. Alejandro, if you wanted to elaborate on that question, I'd be happy to try to answer. But yeah, I'm not doing any, again, everything I'm doing here is just pure Rust. So I'm just using any way to visualize the coverage of tests. I think there are probably tools to visualize test coverage. I know that Covco is a common tool, but I'm the person to ask. But in general, test coverage is something that's built into like your CI pipeline or something. And there are definitely toolings available there. I don't think that I'll go into there now. Oh my gosh, why is it taking so long to compile this number crate? Okay. Well, I would like to wait to show this all works, because I think that doing this without showing it all works is it's kind of missing the point. But I guess hopefully you can see again. I'm going to jump maybe real quick back into the balances palette, the real balances palette, and we can see some patterns again. The pattern that every single module defines a pub trait, which defines the types that it needs. That when we use these types throughout, we're always doing this TS trait or T : account ID or whatever, right? This is how we access these types. One thing I didn't go into was kind of inheriting the types. So you can see there, it's like T account ID. So this is why this is happening, because we've defined the types exactly in the same way in Substrate. Now, one thing I didn't go into is one of the things that we do in Substrate is that the trait for balances actually inherits from the trait for system. So in my example, I created one trait, which is runtime, and it just has all the types defined all in one spot. But you can see here that there's a type being used here, account ID, but it's not defined in the balances trait. It's actually defined in the system trait. But because of this syntax, the balances trait inherits from the system trait. So whatever traits that the balances module needs, it will have to also implement all the system traits. And system trait has account ID. So you could imagine some structure. Okay, it's still compiled. Oh, good. I got some errors. But let me just finish my thought real quick. So you can imagine, instead of defining just one trait here, I might have a trait. Scroll up a little bit. This is where I define the trait. I might have a trait, voting trait, which is just vote index. Oh gosh, the lag makes me just not want to show more examples. I think this is a pretty relevant one. Oh. Wonder if there's anything else in the background of my computer that's causing this problem. Okay, so again, I'm not actually going to follow through with this full thought, but you can imagine that there will be a system trait which just has the account ID type. Oh gosh. Then a voting, a balances trait, which just has the balances type, and then a voting trait, which just has the voting type, right? And I think this example may not be the best because you don't want just one trait to have one type. Like it's kind of a little bit weirder. But you can imagine that balances might need like 2 or 3 types. System needs 4 or 5 types, and you want to separate the definitions with one another. And then when you're implementing runtime, runtime would implement all of these traits. And this is actually what we end up doing in our runtime definition, actually. So if I'll actually just finish this thought real quick. So here we have 3 different traits. In my definition above over there, I would say that that the runtime for balances would need to implement both system and balances trait, and for voting we need to implement both system and voting trait. And then I would have impl balances trait for runtime, impl system trait for runtime, impl voting index trait for runtime, and that's what's happening here in this runtime definition. You can see that we have a bunch of impls. Okay, we're implementing system trait for runtime, and then lower down we're implementing balances trait for runtime, and all these different traits. And so when we pass runtime, it satisfies all these different trait definitions with the types it needs. And so now I have to undo this because I want to fix the compiler errors. So give me 1 second, y'all. I can actually just delete all this. Does that, hopefully that also makes sense, that what I'm showing you is kind of just a simple solution of using a trait, but we just take it one step further by basically having separate unique traits, which only define the parts of the code we want, and get that working. So let's get rid of this. Okay, so what's happening here? Step 5 expected 2 type arguments. So I probably did something wrong here. Voting module step 5. So let's go to step 5. I probably just forgot to update the code there to use the T trait. So if I go to voting here, what I'm expecting is that I didn't update this. Yep. So I just need to flag. Please, a little bit. Scroll up. Okay. So voting module also needs to have the little updates that I've done. Sorry about that. T trait. T colon colon. T colon colon. Here. You guys can see the lag on the other side, right? Like you can see how much I'm waiting. T trait. And then instead of
running like a Rust analyzer or something?
No, I'm not. I think it's just the screen sharing. T. Okay. And then of course I need to just add some T colon colon here. And ideally everything will work. Okay. I'm sorry if this got a little bit slow at the end. Not found in the scope. Okay, yeah. So I think, yeah, this is just some leftover copy paste code. So here, I want to define this as, I think, runtime. Oops. Runtime account ID, I think will work. Ambiguous associated type. Okay, yeah, it wants a full. Yeah, then you might actually see, you might have seen this error before in one of your substrate things. So I think it's just here just complaining that it doesn't know exactly how to access this trait. So I will do runtime as trait. Yeah, the error here is actually a little bit misleading because I don't need to do this test step 5 thing, but I just need to do runtime as trait. So basically I'm saying access the runtime struct as it satisfying this trait. And we know that trait has a count ID, so then it will have access to this type. I'm actually not sure why it would be ambiguous, because there's only one account ID defined here, but I won't go into it. Oh, and then it says one more error I got here was can't leak a private trait. And so I just need to basically make all these pub, I believe. I don't know if you were able to see that error message, but I think if I just make these pub, I will get what I want. Okay, one more time, please. Oops, not cargo run, cargo test. I'm feeling pretty soon to give up on this because I do know it works. It's just pub is not implemented here because it's implied. Okay, then what did I do? Let me take a quick look at my cheat sheet and see if I'm catching any errors. If anyone has any ideas, something about the type definition. I think a cheat actually be just because I know that I know the account ID is U32 here. I think I can just define this as a U32, or just have no definition at all and let it be implied. But there should be a way to hard code these type definitions. But for the sake of time, and because my computer is lagging so much, let's see if we can just get this to work. Can't leak private trait. Oh, is it because this is not a pub trait? Let me take a quick look at my code real quick. Sorry. I think somewhere I'm missing a pub. I think it might be on this trait definition up here. Oh yeah, I just need to add a pub trait here, it seems. Which is weird. I guess it's not weird. I guess it's what Rust likes to do. Please. Yeah, okay, cool. It all works. Step 5 works. Everything is good. Okay, so that captures the main part of what I wanted to talk about today. What time is it? Do we have time to jump into other stuff? I feel like it just took a little bit longer than I expected. Yeah.
Yeah, we have about 20 minutes.
Yeah, so I wanted to also go into macro magic stuff. So hopefully, again, this was useful to people. You can really see in the background how we got to exactly the syntax and formatting that we use in Substrate. And it hopefully makes this entire thing not macro magic, not Substrate magic, but just Rust. It is just the natural conclusion you would come to when trying to design a system like we were doing with the Substrate runtime. So hopefully this is enlightening. The other thing I wanted to talk about was macros, but I'm not sure if we'll have time today. Maybe I can come on another time and talk about that too. Maybe I can also figure out my lagging issue. But what I wanted to show you, and maybe I can just give you a sneak preview. I think I won't go into this topic today. But what I want to show you is kind of just a little bit of, I think macro magic is one of those things that's hard to overcome. Like inside of macros is syntax that that's not real Rust. It can do things that you're not sure about. Why do we use macros? Like all these kinds of questions. And I wanted to show you kind of a naive implementation of declare module, not actually doing any of the more powerful stuff, but doing something simple like implementing onInitialize. So we know that every palette can have an onInitialize function. But kind of how does that work in the background? What does adding an onInitialize function do to my module? And so I guess the high-level talking points I would want to cover on this is that declare that the macros, are a lot of magic, but can make sense once you start to understand kind of how we approach it. And the general way we approach these macros is through some kind of like recursive parsing, where here I have some declare module, and it has some initial syntax that I expect. And what we do is we recursively parse and parse and parse this the content inside the macro until we get to a format that has all the pieces we want, and then we construct the final code we want. So maybe this is a little bit too small. Maybe make this a little bit bigger. But just to give you a quick idea, and I'll just talk about the steps in terms of logic. There's an entry point where you declare module. Inside declare module is expected some struct with a module in it and some code. And then we say, okay, well, let's check the first condition. The first condition is that onInitialize is defined. If onInitialize is defined, we can basically match that in our macro and capture that definition into its own special little object. If it's not defined, what we do is we detect it's not defined. It wasn't there because it didn't match this first arm. So we got this arm, so it must be there. If it's not there, then we can define our own onInitialize with our own implementation in it, right? So here we've implemented onInitialize ourselves. It says not implemented, right? And so in both cases, at the end of these two matching arms, if it was initialized, we capture what you put there. If it was not initialized, we put something in ourselves. And so at the end of the macro, we know 100% there is something there for onInitialize, whether the macro put it there as like doing nothing or you put it there. And then what we can do is implement actually this trait onInitialize using this function definition. So again, this is a lot to talk about right now. I think that it would be good if this was an interesting topic for people, I can actually walk through writing this macro and kind of how the parsing works. But one thing to definitely take a look at is, when you're writing these macros, what we're doing is why the macros are kind of so strict in how they're formed and why they complain so quickly when you just have a small typo or missing some small thing is because we're constantly matching macros to some expected syntax. And if for whatever reason you change that syntax a little bit to something it doesn't expect, you would have to basically create a matching arm to capture, this possible error. And while we have done this for a lot of things, you can imagine that all the possible errors for all the possible matching arms is just too much, right? And this is why macros can sometimes be really frustrating to work with. But in the end of the day, it actually saves a lot of time for the end user. And it's really powerful. So I think that's all I wanted to talk about today. So I guess if there's any more questions or any other things that we wanted to talk about, I'm here and I'm happy to share my knowledge about Substrate in any topic. Yes, it says you can also expand the macros if you want to see what the code actually looks like. So yeah, you can definitely do that. Expanding the macros, I think, produces sometimes really nasty code. But if you're willing to kind of, if you have a high level understanding of what the structure should look like, then I think it can make a lot more sense. But I think walking through like the construction of a simple macro can really be enlightening to how it works. And this is something that I experienced recently when I was writing my own macro for benchmarking and stuff. Yeah. Okay, so yeah, which VS Code theme is that? I think I just used the dark theme. It's like or maybe the black theme. I forget.
Dark.
Yeah, one of the default ones. Okay. Joshi asked, okay, let's talk about benchmarking macros. Or Chris, how do you use the benchmarking macros to figure out weights? So I kind of talked to Joshi about this offline, but I think that going into weights will kind of be will be a much longer topic, would be a lot to cover. But I can definitely go into a general overview of what benchmarking looks like and kind of what you might expect when you need to end up benchmarking your own code. But when it comes down to actually doing the process and making everything work and knowing all the best practices, definitely a much longer conversation will need to have happened. But this is actually how I kind of got introduced into like forcing myself to learn more macro stuff, was that I was working on this benchmarking macro. And so let's take a look at maybe how the final benchmarking and weight system might work or might look like for palettes. And we'll do that by taking an example of the balances palette, and we can walk through all the different pieces of benchmarking there. Okay, so what you should be familiar with if you have written your own palette is that you have in the palette a bunch of extrinsics. And these extrinsics obviously can be called by users. And then there's this weight value. This weight value describes the complexity of calling this function to the blockchain. In the case of Substrate, where we have these we have consensus which has like a fixed block time, what this weight value really represents is how much time does it take to execute this extrinsic function, right? So if my block time is going to be 3 seconds, and it takes 1 second to execute a transaction, and that would be a really shit blockchain, you could do at most 3 transactions in a block, right, of 3 seconds. Now, we're talking about, thousands of transactions. Like we've benchmarked in Substrate that we can do like 1,500 transactions per second on a blockchain that has 3 second block time and stuff like that. But what we basically have here are these extrinsics, and then some weight, at this weight annotation at the top, which says, okay, this is how expensive this function is. And this weight annotation is basically a function which can itself have some inputs. For example, it could input the values you're passing to transfer to try to help determine the weight of the function. So in the case of transfer, no matter who's transferring to who, the weight of transfer is always the same. But there might be a function like Fibonacci, like calculate the Fibonacci number, where it says calculate Fibonacci number of n, where n is how deep you want to go in the Fibonacci sequence. And the larger n is, the more weight it would take, the more computational complexity there is. So you could have a function like, get the weight of Fibonacci for n, and it would actually calculate a new weight based on how deep you asked for the function to go. But in general, there's a extrinsic here transfer, and there's a weight annotation up here which says what the weight of this function is. And so let's talk about how we get to this weight. So what this weight info is doing, this is a new standard we're going to be introducing into Substrate, and I'm actually working on migrating a bunch of palettes to this now. But every palette, at least in our palettes, will have this additional type, weight info. And weight info will implement basically a function which will return the weight for every extrinsic in your chain. So here we have a weight info transfer, which returns the weight for transfer. Here we have weight info set balance, and you can actually see this one's kind of a little bit different. Set balance can have two different pathways. In one pathway, we can set the balance of a user and create a new account. Another one, we can set the balance of a user and kill an account, right? We can set the balance to 0 or set the balance to some number that's not 0. And so here we actually have two different weight formulas for set balance. And here in our weight annotation, we say, okay, we're going to say the weight of this function is the bigger of the two. So of course you can add more logic if you wanted, but for the sake of the balances palette, it's good enough to say, okay, well, one of these might be slightly larger than the other. We're just going to say whichever weight is bigger, that's the weight of this function. And again, I'll show you a little bit more details here later, but you can see every single extrinsic will have this weight info at the top of the function. So let's look at where this weight info is coming from. So this weight info is actually coming from two places. Actually, I need to go back actually. This weight info is coming from the same thing we've been talking about all day, the trait of this palette. So if I go back up to the trait of this balances palette, maybe it'll be easier if I search trait. Oh my gosh, the lag is so real. Give me 1 second real quick. Let me try trait. Nope, one more. Okay, so we've introduced this new type here, weight info, which must satisfy a trait called weight info. Yeah, sorry about the naming here. It couldn't get really clever here. And if I look for a trait weight info, each palette will define this trait weight info, which will, which will have a set of functions that must be defined to satisfy this weight info. So you can see here I've defined that if you want to be able to correctly weight the balances palette, you must satisfy and give me a function for transfer keep alive, set balance creating, set balance killing, and force transfer. And you must give me these 6 functions or 5 functions that return a weight for that extrinsic. And so this is where the whole benchmarking pipeline comes in. The final thing might look like something like this. So every palette, we give you this default weight. And the end of the entire benchmarking pipeline will automatically generate for you this file. And this file will basically implement this weight info trait and will create all these functions for you, which return a weight, which has some base value plus some weight value based on the reads and writes of the DB operations in your extrinsic. And this is what I've been working on really hard for a while now, that we've been working to automate this entire thing. So if you can write a benchmark and execute that benchmark, we can automatically detect for you how long it took for the base speed and how many read and write operations you did in your database and construct these formulas for you automatically. And then you can just pass these values to the palette and it will use these values for the weights. Now, one of the things, the reason why we moved to this pattern, if you're familiar with old weights, you used to be able to just hard code, weight is this in the palette. Well, we know that these different runtime palettes can be configured in different ways. For example, in the balances palette, you can configure so that the balances are stored in the balances palette, or the balances are stored in the system palette. Now, storing it in the system palette is actually more efficient, because whenever you do a transfer, we need to increment the nonce of a user, we need to increment the balance of a user, we need to do other things like that. If we have the balances in the same spot as the nonce, instead of doing 2 reads and writes when we update a user's balance by a transfer, we only need to do 1 read and write. So updating the balance of a user is just 1 database read operation. And database reads and writes are often one of the most expensive things about Substrate, or using the Substrate runtime. But if you wanted to, for whatever reason, your blockchain wants to keep the balances separately, you can do that, configure the palette differently, and instead of being 1 read and write, as you see here in transfer, it would be 2 reads and writes. But if we hard-coded this value into the balances palette, that means no matter who uses the balances palette and how they configured it, that they would have hard-coded into it the way that we configured it. And this is not good. We want other users who use our palettes in different ways to be able to give weights that are representative of their blockchain. For example, you could have a different benchmarking machine than us, or you could have a different requirements, or a bunch of different things. So in the way we've defined it here, we provide you a default weight, but in your runtime definition, you can actually pass your own weights, which will override the defaults and will be used by the runtime. So if we go here to node, runtime, source, anyone who's building their own runtime can create this weights folder, which has a list of all the weights that they want to define. So this is the weights that we've defined for our system and our configuration, our specific setup. And we can pass this weight info, this specific thing, into our runtime definition. So if we go here to librs, and if I go to palette, balances, weight, info. Yeah, perfect. So you can see here that in my balance balances trait, I'm passing to it not the defaults, but my own weights as an override. So if I wanted, for whatever reason, wanted to make transfers really expensive on my blockchain, increase the weight a lot because I found some issue with my chain, I could go update my specific file and add some more zeros here, right? Ideally, you're not doing this by hand, but all of this would be generated for you. So you run the benchmarking utility on your runtime, and it will generate a file unique to your setup and unique to your needs, and it will pass it. And so all of the different palettes will have their own inputs, and you can go and do that. So then I just want to give you a quick look into what a benchmarking setup might look like. And to be honest, the benchmarking setup is just basically like writing tests. So there's a file here, benchmarking, and benchmarking uses a macro which I helped work on called benchmarks. And benchmarks basically expects there to be a set of functions that you define. And the syntax is a little bit funny. Again, we don't use real Rust syntax here. Again, it's something I can talk into more if I run over the Rust macros. But basically here, I want to test a transfer. So basically what I need to do is basically create a test. I basically set up a caller, set up a balance for that caller, set up a recipient, and then I call the function transfer using the origin of the caller, the recipient, and the transfer amount. And so I've here defined what is needed to set up a balance transfer call to actually do the transfer call. And here I even have a verify block, which verifies that my test completed successfully, like that the result is what I expected. So in the case of transfer, I want to make sure that the caller, their account is always killed. Their account always goes from some balance to 0, right? And you can see here that here I say transfer will always kill the sender account. This is the worst case scenario. And whenever you're benchmarking your runtime, you always want to test the worst case scenario. What happens in the absolute worst situation? In this case, when I do a transfer, the worst thing that can happen is that I create a new account and I kill the existing account. You can see here, my assertions here check that the free balance of the caller is 0 and the free balance of the recipient is some not 0 amount. And you can check, I probably checked beforehand, or maybe I don't, but I mean, it's the balance of the original recipient is 0. And so here I have basically a test right? That tests the worst case scenario. And then I can compile my node with a special feature. It will be here. Let me open this thing. Let me open my command line. I would basically compile my thing with a special feature. So I do cargo build release, just like you would do to build your node, but add the feature flag features runtime benchmarks, and this will tell the rest of the code to add this benchmarking feature to your runtime. And then when you have this feature runtime benchmarks, you're able to run something like there will be a command. So this will build a binary with the runtime benchmarks feature enabled. And so let me go to that binary. So I'll do target release node. I think it's Substrate, actually. Substrate. Benchmark is the tag for our benchmarking pipeline. And then I can do something like palette balances, extrinsics. I can do all of them. I think it's just singular. And I can do output. And there's other flags you want to type into. Like actually, you want to type in execution equals WASM. So you always want to test with WASM execution. This is the worst case scenario for your blockchain. But we want to test using the WASM execution equals compiled. We want to use the compiled WASM execution environment. And then we can also do things like the number of repeats. So we'll repeat the benchmark 20 times. And then also steps. Steps is not really being used here in the balances thing, but you can imagine that for something like the Fibonacci number, you need to benchmark the Fibonacci extrinsic over different values. So like, what is Fibonacci? How long does it take to run when Fibonacci is 1, when it's 10, 100, 300? So steps will tell you how many steps I want to take between the ranges I want to test. So for this case, I'll do steps equals 10 just for whatever. And I think this will give me a file if everything went well. The computer's nice and slow, so it'll be a while before it tells us anything happens. Compiled wasn't expected. Is that wrong? I think that's right. If it's not right, then execution equals WASM. WASM execution equals compiled. Oh, here we go. I guess spaces, it didn't like spaces, which makes sense. It thinks it's a param. So you can see here, it's running the benchmark. Now my machine with the lag and all that kind of stuff will be quite slow, but you will see here that after writing these benchmarks in your palette and making sure they're right, having the test and whatever, you can just simply run the benchmark, and ideally we'll see at the end of this a file being generated. Yeah, you see, but there's a bunch of output. You can capture this output if you want. But the cool thing that I've been working on here is that look at this new file, palette balances.rs. And here is an auto-generated file with all the weights for my machine, with the reads and writes and everything already programmed in there. And all you need to do is actually add this to your CI pipeline. And every time someone pushes an update to one of their palettes, you can have CI basically run the benchmarks on some hosted machine and push to the branch the new weights file. And so this is kind of the pattern we're going to be using moving forward, where basically all weights are auto-generated and completely automagical and amazing. Anyway, I mean, and even this was kind of a long-winded speech, but I didn't even go into the details about writing the benchmarks, what it would take to test it, worst-case scenarios, stuff like that. So what I'm showing here is kind of even itself a high-level overview. Writing benchmarks, I think, will be a quite complex process for even good runtime developers. So making sure you're doing it right is something that's going to be hard, and I'm sure there'll be more documentation coming out, but I've been working to make the pipeline literally automatic for users, so it is that simple and easy to use. Cool.
Nice. That was awesome. Thanks, Sean.
Cool. I see a question from Steve. When specifying the compact tag attribute on dispatchable arguments, does it add support for scale compact encodings or makes it mandatory? I believe it makes it mandatory. I mean, when you add the compact, it is expecting a compact argument. So I don't think it's like you can get one or the other. I think it's just if you say it's compact, you should pass it compact. Otherwise, it will parse your blob in some wrong way. You have to remember that all of the types in Substrate, like the coded bits, are not self-descriptive, right? So there's no way for something to know, like, this could be compact or this could not be compact, right? Like it has to be a known format. So if you're telling the runtime, hey, expect a compact, it should be compact. Otherwise, it'll parse it wrong. Any other questions? I hope, Joshi, this was enough of a overview of benchmarking, at least for now.
Yeah, it would be cool to have you back on here and do some like high level, maybe mid review kind of level overview of like weights and benchmarking and more specific stuff. I think there's a lot of us who are really interested. But Josh, you said awesome things. Overviews, awesome things.
Sure. Yeah, I'm happy to talk about it. I think my main focus right now is just to basically get the benchmarks into this final pipeline. So this using this weight info trait is something that's actually quite new. It's something that we got feedback from users that like, hey, you were telling us what the weights, but we're configuring our runtime differently, and these weights don't apply to us. So we redesigned it like this, and I want to push everything out there for version 2.0. And of course, once version 2.0 comes out, it's stabilized, and then yeah, it's much easier to talk about all these things once they're stabilized. Cool. Yeah, if you had asked me about these weight stuff maybe a month ago, it would have looked a little bit different. And so you can see how kind of cutting edge this is. And if you're using the weights right now, definitely feedback to me or to anyone else on the Substrate team would be a great way to make sure that you get your voice heard in kind of the things you were looking for in these weights.
Yeah, what's your preferred way to get feedback from developers? Like, do they want them to pull a PR issue, like get in the Riot channels? How's the best way to get a hold of you?
Yeah, I think, so I'm very active in the Riot channels. I think the best way is to propose your idea in the Substrate technical channel, not only for myself, but for everyone else to see and just kind of get an idea of the thing. And if it sounds like a good idea, probably the natural thing I would ask you to do is then open an issue. Opening issue first is fine too, but sometimes it makes sense to just like talk about it, or maybe something that we're already working on or whatever. So just asking us like, hey, it's a reasonable idea, maybe talk back and forth about it, and then opening an issue which represents the idea well, and then someone can work on that. Or even better yet, if this is your idea and you have the will to go ahead and do it, having someone mentor you and actually help you complete that task would be the ultimate thing.
Yeah, awesome. I agree. I think that's it. We don't seem to have any more questions. People are saying thanks already. So yeah, I really appreciate your time coming on today. This has been super helpful for all of us on the dev team. And I think a lot of people are really excited to hear more about everything with Russ. So awesome. We really appreciate it.
Yeah. Okay, sorry about the laggy computer, but hopefully I can fix that the next time I'm on.
Yeah, and I'll post the repos on the DevHub GitHub. Well, I can't talk anymore. I'll post the repos on the GitHub for the GitHub on the Riot channel for anyone who's interested, specifically the DevHub one. So feel free to check those out if you didn't get them earlier.
Awesome. Cool.
Yeah, thanks, guys. Have a great day.